To finish out our basic quadrilateral shapes, we need to talk about trapezoids. A quadrilateral is any shape that has 4 sides and 4 angles. So these are all examples of quadrilaterals. All quadrilaterals have an interior angle sum of 360 degrees. If you add up all 4 angles, you get 360 degrees, regardless of whether it's a parallelogram, a rectangle, a square, a trapezoid, or any quadrilateral shape. Trapezoids are a special kind of quadrilateral. They're the only quadrilateral that we've been talking about, or the only specific quadrilateral that is not a parallelogram. Parallelograms have special properties based on the fact that they have 2 sets of opposite parallel sides. Trapezoids only have 1 set of parallel sides. We know that this shape to the right is a quadrilateral. We know it has 1 set of parallel lines because it's marked like that. The bases refer to the 2 parallel sides. We often label them as base 1 and base 2. The height, just like the altitude or height of a triangle or a rectangle, square, etc., is the perpendicular distance between the 2 bases of the trapezoid. So the key word here is perpendicular. It's a line that makes a 90-degree angle with one of the bases and, in this case, both of the bases. This is how tall the shape is. The midsegment of a trapezoid refers to the segment that's connecting the midpoints of the 2 non-parallel sides. Our 2 parallel sides are the bases. The other 2 sides are often referred to as legs or just sides. The midpoint is the point on each of those sides that cuts it in half. This midsegment can be measured using the bases that are given. Base 1 plus base 2 divided by 2. So let's try a problem. In this case, my bases are 6 inches and 7 inches. I always start by writing out my formula. If it helps, label base 1 and base 2 on your diagram so you know exactly which values you're referring to when you substitute them into the formula. I'm going to substitute them in. Base 1 is 6, base 2 is 7. And now I can just plug and chug. 6 plus 7 is 13. 13 divided by 2 gives me 6.5 inches. We're really taking the mean average of your 2 bases. To find the area of a trapezoid, there's a specific formula that you need to know. Just like any closed geometric object, the area is the number of unit squares that can fit inside of this object. The area represents the 2-dimensional space that this object takes. To calculate the area of a trapezoid, it's 1/2 times base 1 plus base 2 times height. Notice there's parentheses around base 1 and base 2. When you follow your order of operations, you'll need to add that value, multiply it by 1/2, and then multiply the subsequent product times the height. Let's try an example problem. Always start by writing out the general formula. A equals 1/2 B1 plus B sub 2 times height. If it helps, label these measurements within your diagram. Base 1 is 6, height is 5, and base 2 is 7. The bases are always the parallel sides of the trapezoid, and the height is always the perpendicular distance between these bases. I just need to substitute those values in. 1/2 times 6 for base 1 plus 7 for base 2 times 5 for the height. I would have to calculate this following the order of operations. 6 plus 7 is 13. 13 times 1/2 is going to give me 6.5. 6.5 times 5 gives me 32.5 inches squared. The unit for area is always squared. 6 inches, 5 inches, 7 inches, 32.5 inches squared for the unit. On your own, use your formula 1/2 times the sum of base 1 and base 2 times height to solve for the area of these 2 trapezoids. Let's look at the area of a trapezoid from the perspective of finding an individual measurement. If I need to find an individual measurement or a missing value, in this case base 2 is missing, I'm going to set up an equation. I always look at my general formula. The general formula is your friend no matter what. I know my height, I know base 2, I know base 1. Now that I have my givens label and the area, I can use the formula to solve for base 2. As long as I only have one missing value or missing variable, I can solve using my equation. So I'm going to plug everything I know in. I know that the area is 130 inches squared. I know that base 1 is 12 inches. I know that the height is the base 2 is unknown, so I put in a variable, and the height is 10. This gives us a complex multi-step equation. 130 equals 1/2 times 12 plus x times 10. We actually have distribution in this case because of the way the formula is set up on both sides. So I can multiply both terms inside of the parentheses times 1/2. Half of 12 is 6 and half of x is 1/2 x. Now I need to multiply by that 10. 10 times 6 is 60. 10 times 1/2 is 5x. What you're really doing is multiplying the two terms inside the parentheses by 5. 12 times 5 is 60. X times 5 is 5x. This is a two-step equation, so I'm going to subtract 60 from both sides and then divide both sides by 5. When I do this, I end up with base 2 equaling 14 inches. Even though area is involved here, I'm not finding the area, so my unit is just going to have a single exponent. So it's just inches, not inches squared. On your own, find the missing value using the formula for area of each of these two trapezoids. Let's take a moment to look at quadrilaterals as a whole and see where trapezoids fit in. We have quadrilaterals all together. All shapes are four sides. Within that, we have parallelograms. Now, parallelograms still have four sides. Their angles or interior angles still add up to 360, but all opposite sides are parallel. This means that all opposite angles are congruent and all opposite sides are congruent as well. They're all the same measure. Within parallelograms, we have a couple different major areas. We have rhombuses or rhombi. What makes rhombuses and rhombi special is that all four of the sides are congruent. This still means that the opposite sides are congruent, but now all four of the opposite sides are congruent. We also have rectangles. What rhombuses do to the parallelogram rules, rectangles do to angles. So we have opposite angles that are congruent, but now all four angles are congruent. If all four are congruent, that gives us 90-degree angles with all rectangles. In the middle of rhombuses and rectangles, we have squares. Squares are four-sided quadrilaterals with opposite parallel sides. All four sides are congruent and all four angles are congruent. Within quadrilaterals, but outside of parallelograms, we have trapezoids. What makes trapezoids special is that it has one set of opposite parallel sides.